So for the application problems, I just want to go over some useful formulas that you'll want to keep in mind and some keywords that you'll want to look for. So for any sort of compounding continuously model, this is the formula you should be familiar with. A is equal to P times E to the RT. A is always the ending amount. P is always your starting or your initial. R is always your rate. And remember that it should be written as a decimal. And T is always time. Generally, we say that is in years. And E, remember, is just a number here. So compounding on an interval, that's when you're compounding over daily, monthly, quarterly. So that's going to be a different formula. That is the A is equal to P times 1 plus R over N raised to the NT. And you would know that by some keywords, again, being like compounding monthly, compounding, well, sometimes it's annually, quarterly, daily. And remember that these all have to do with the N value. The A and the P and the R still hold the same as the compounding continuously. An exponential growth model, growth is basically the key word here when it's talking about something growing and you're not given a specific formula. You want to use A is equal to P times 1 plus R raised to the T. And again, you'd be looking for the words increasing or growing in order to know what, or in order to know to use this model. Exponential decay, sometimes the keywords here are decreasing. Sometimes you'll see the word depreciating. Those would be keywords for you to know to use this model. A is equal to P times 1 minus R to the T. And it's easy to remember the growth versus decay. Growth, you're growing, so you should be adding. Decay, you're decreasing, so you should be